Hello. Welcome, everybody. Thank you for coming today. My name is Franklin Angulo. I'm one of the directors of engineering here at Squarespace, focusing more on the server engineering side of things. So SRE and all the backend Java development teams that we have over here. Let's see if this works. So before I delve into the talk today, I wanted to introduce Squarespace as a company for those of you who do not know what it is that we do. So we are a platform that powers millions of customers to put an online presence for their business or for themselves in the form of a domain, a website, or a store. We've been around since 2004, and we just recently moved to this office, actually a year ago. And when I joined, Squarespace was about 30 engineers. It was in the summer of 2013. And I've seen the company grow at a pace a very fast pace. Right now, we're a total of around 120 just in engineering. So from 30 to 120. And as you see the company grow, a lot of things break. Communication line break, technology breaks. And of course, as the company grows also in customer base, some of the things don't scale anymore. So the talk today will be about what we had to do to change to handle not only more people that are in engineering, but more people that use our platform. So the first example I'll give you is of the architecture that we had way back when. We had user requests, either people interacting with their websites by editing or adding new blog posts, or people visiting some of our customers. All of that traffic entered a series of web servers that responded to requests in a dynamic way. And then we had another fleet of servers that handle background tasks or asynchronous tasks. So an example might be somebody uploads an image, and that image you have to create a bunch of variants for. We would handle that in the background because the user doesn't necessarily have to wait for that. Other things are email delivery and a bunch of other stuff that you can imagine. As you add more and more people to this basically monolith architecture, when a developer pushes some code that blows up the server, everything goes down because it's the single code base, single deliverable, single deployable artifact. This is not ideal. What we wanted to do, and we started doing this in June of 2014, was a more distributed architecture following the principles of service-oriented architecture, where if you have a bunch of features that power your platform, you can segregate them and develop them separately, such that if the search functionality breaks down because your Elasticsearch or Solar cluster dies for some reason, only the search functionality dies, and all of the rest of the features continue to function normally. Another thing we were looking for is if we add more customers and they all use our functionality for image processing, our websites are they show images a lot. So of course, as more customers join, more images need to get processed. So you should be able to scale that particular service more than the rest of the platform. In the previous architecture, you would have to scale the entire fleets for just one use case. Before I go there, the rest of the talk will be about, one, why we wanted to do this, and two, what we thought about as we embarked in the journey of building a microservice framework. So we will touch on 4 areas. First and foremost is, as you see all the lines in that diagram, more services need to communicate with other services. So we need to ensure that the communication mechanisms through the clients is top-notch. The second one is, if you're going to build a microservice, the core framework that supports that service also needs to be very robust. The third area will be how, as a engineering team, you integrate with other teams in the organization and also with the SRE team so that we use centralized things such as time series databases and log aggregation frameworks. And finally, how do you get people to use your framework? So we can start with the service client. We call our framework Tyson. We don't necessarily know why, but it's just the name we gave to it. And when we were thinking about what would a service client actually need, we thought about these four areas: client-side load balancing, latency and fault tolerance, client-side caching, and HTTP request builders. The first area is client-side load balancing. So if you are an application and you want to interact with a bunch of other services, or one service in this example, you need to have a way to go find out for service X, which is the fleet. And once you do that through a mechanism of service discovery, you should be able to load balance across all of those servers. So this was our first requirement. It didn't necessarily matter for us which implementation of service discovery we chose. So we now support Zookeeper on console. The next one is latency and fault tolerance. And this is where, as you move away from a monolith and into a microservice framework, like, it doesn't come for free. So there are many other ways that the microservice can break that the monolith didn't break. So this is one example of those. So let's say that to fulfill a request from a customer, you have to fan out and call 3 different services. Your application container, might be Jetty, will have 3 different service clients to be able to communicate with the 3 different services. But if for some reason service 3 breaks down, you are not able to successfully return a response to that customer. So how do you handle this use case? And it might be that the service has high latency because of a dependency that it has, or that it broke down or is overloaded, whatever it might be. So what we decided on doing was these 3 service clients that the application container has to communicate with other services will, in each of them, have thread pools. And those thread pools will be, that's the way you limit how many requests you can go make to the other services. And if for some reason service C has an issue, the user requests that are, to be able to fulfill the user requests through service C client, those things will fail in a managed way. And you can choose the way you want to fail. So you can fail fast, silently, or you can fall back to a cached response, for example. And in this way, even if the user request wasn't able to be made to service C, you can still respond in a good way to your user by saying this is offline or showing something else. The third one is client-side caching. And this is pretty straightforward. If you're making a bunch of calls to service X, you don't want to make the same calls all of the time. You should have some intelligent mechanism to tell your service client, if you're seeing the same request all the time, keep a cached version in your heap and just return that. It limits the amount of requests you need to make. And finally, HTTP request builders. We wanted to make it extremely simple for a developer to define that they want to interact with one service and build the template for the specific endpoint that they wanted to call. So a note here, for all the things that I've mentioned in the past few slides, we used a bunch of technologies that Netflix open sourced, specifically the Ribbon client and the Hystrix technology that it lives within the Ribbon client. So that is the service client. How do I, as an application, communicate with other microservices? Then the other topic is, how do I build a new microservice? And what features will I have in there to support my operations? So we will cover all these 10 areas one by one. First one is health checks. So pretty straightforward. If I have a taxation service like here, what we do for health checks is that you define the server port, which is where you will be receiving HTTP requests. But then you also have a management port where you can do things like asking the service, are you healthy or not? Or also you can publish metrics through that or expose metrics through that. This is an example where I have an instance of our taxation service in production in the management port 8081, and I tell it, give me your health statistics. and you get a JSON response back, and you can act upon that, either at your load balancing layers or anywhere else that you might need. The next one is service discovery and registration. So if I am a service and I come to life, how do I register myself and tell the service discovery mechanism that I should or that I want to receive traffic? So we embedded this into the core framework, where if you're a service A and you come up, you know how to tell the service discovery mechanism, I want to register myself as part of this fleet of servers. And again, we have support for Zookeeper and Console. So in this example, we're using the console-based service registration. So we have the same taxation server, and you can see in the console UI that it's running a check against localhost 8080 for that specific server, and it responds successfully for that health check endpoint, and console says this node is alive and it should be able to receive traffic. Next topic is contextual information. If I have a billing service that needs to make a call to a taxation service to determine how much tax it should charge a customer as they go through the checkout flow, I need to understand the series of things that are happening here. First and foremost, I want to understand what is the client source type. In this case, it's a billing server. And secondly, which version of the client is this server using? And in this case, it's using version 3.1. And finally, because this becomes a very complex distributed system, you need a way to track requests as they flow through the different microservices all the way back to where they originated. So what we do is that we put a header in those requests and generate a context ID. So if this billing service calls taxation service, which itself calls another service, you can use that context ID to parse the whole request tree and know what happened during that request. So we wanted to understand, to provide context to our developers about what was happening with their requests. And then based on that information, you can build structured logging. So for the same example taxation service, I want to differentiate from access logs, which are just telling me what requests I'm receiving and the response I'm giving back. Application logs, which is in our case, the Java application saying what they're doing. So developers might put log statements at different levels, info, error, or debug. That should be separate than the access logs. And finally, some other types of logs like garbage collection for Java or any other language that you might be using. So we made it very simple for a developer to define the logging configuration that they wanted to use. So this thing on the left is the configuration that you define in your deployments of your service, where you say, my top level logging level will be debugging mode. For the different types of packages in my Java application, I want to do different things in terms of logging levels. And then you can even define the directory, the extension of your logs, and things for retention and rotation of those logs. And then on the right side, you see an example access log with the contextual information that we covered in the previous slide, where you can see the thread that it's using, the URI that it was trying to hit with what parameters, and response times, and so on and so forth. But more importantly, you can get all of the context that you need about where did this request come from which client version, and from which type of server. Related to logging, you also want metrics. So we also made it very simple for services that use our Java framework, that you can enable the Quota Hail metrics library that will generate metrics for every endpoint that you have, or for anything else that you instrument in your application. And all you have to really do is say, Graphite, I want to enable it. And these are the hosts. This is the host and the port that will be used. And we will cover how, this is a template. We will cover how when you deploy, all of that information gets inserted magically through Ansible, so that if the names or the quantity of hosts for Graphite change, you don't have to worry about that as a developer. It gets provided to you through the system. So if you enable the Graphite metric reporting, you can go to the same management port for your service and go and type /metrics, and you get a bunch of different metrics that internally Quota Hill aggregates and sends to your Graphite cluster every 10 seconds or however long you define. So if you have a service running with Graphite metrics enabled, you can go through to Grafana and build your query string, and you will easily see all of the, in this case, all the requests to the taxation rates API endpoint. I also mentioned that we use Hystrix for latency and fault tolerance. So for free, if you use our framework, you also get Hystrix dashboards that tell you how each of your endpoints is doing. And these dashboards are pretty neat. You can focus on each of the quadrants, and you can say, for my billing get currency format endpoint, you see 6 different numbers near the middle, which correspond to successful, short-circuited, bad requests, timeouts, rejected failure, and then error rates. So you can easily see for the one at the top left, you've had 60 successful requests since you loaded the dashboard, and everything else seems healthy. You even get latencies and so on and so forth. So this is very short-lived data. It's real-time data. So it's a complement to what you get through Graphite. It also tells you whether your circuit is closed or open based on the health of that service and endpoint. So apart from metrics and logging, the other component that forms the triad is distributed tracing. So as a developer, again, you don't have to do anything to have distributed tracing enabled for you. We will bake it into the framework. So in this example, I have, if you follow the waterfall, you see that the first component is site server. Those are our web servers. And in this example, you can see that site server is making a bunch of different calls. Some of them to the location service. We have instrumented distributed tracing to also trace the MongoDB calls, the Elasticsearch calls. So you can very easily see what is happening in a particular request, why it's taking so long. And you don't have to guess as to why it's taking so long. It will tell you why it is. And again, this is done for all of our services. So if you see our graph of calls made between services, you can say, I want traces for billing service to taxation service or over this span of time, and drill down based on that. We'll cover a little bit more about the configuration that you have control over as a developer. Specifically, we don't trace every single request. You have to provide a sample rate. So for example, you want to trace 1% or 10% of all the requests, and then we'll take care of that for you. Another component is dynamic configuration. When you deploy your service, and something goes wrong because you need to tweak a setting, you don't want to rebuild and redeploy that piece of configuration because it might take too long and it might cause downtime. So there are pieces of configuration that we provide you the ability to change dynamically. And this is the example of tracing. You can dynamically change the sampling rate for your tracing so that if you have an issue currently in production, you can bump up the tracing level so you can drill down. And as soon as you have identified your issue, you bump it back down to the normal level. And this is the only thing you need to do. You define variables, define a name for your variable, and for each of the individual environments that you have, you can define the value. What happens here is that gets persisted into console, and this is where you would go to change the values in real time to affect your service. So in here, I'm saying the billing service tracing sample rate, which was 1 before, I want to change it to 77%. Next thing, standardized deployment. If you're gonna build a service, you have a Java code base, you wanna build it, you have your Gradle config file and everything, and knows how to build itself. After you have generated an artifact in a WAR file or a jar file, you wanna push it somewhere. We control all of that for you and give you Ansible managed deployment. each service repository houses not only its configuration file, but also its deployment script. Configuration files are Jinja 2 templates based on Ansible, and deployment scripts are just another YAML file that is in Ansible syntax, and we'll see examples of those. The main driver for this was that you should not require involvement from SRE to deploy your service, and we want to make it self-service where you as a developer have complete control over not only your infrastructure for your service, but your build and your deploys. SRE would not like to be a blocker for that. I think this is the last one, API documentation. If you have a service, hopefully people will want to use it if you make them generic enough. We want there to be no barrier to entry for using your service. And a big component to doing that is having API documentation. We do so through Swagger. So if you have, this is the billing service, if you have defined the service per our standards and use our models, you will get for free API documentation for every one of your endpoints. And not only that, you can actually try them out in real time by filling out the individual forms. So I believe I had an example here. I'm going to load the Swagger spec for Swagger UI for location service, and I'm going to say that I want to find the IP or the location for this particular IP. And this is the location in the production environment. I'm just going to put something in here and say try, and it will tell me that I am in New York and give me a bunch of other information. This is live in production, so as a potential consumer of your service, I can play around with your endpoints to see if they're going to meet my needs so that I can adopt them. So that's what we provide through API documentation. That covers the core. So with those 10 pieces of like the base of the core framework, you as a developer can have a very robust, not only service, but a bunch of tools around it that support your development and your consumers. The third topic is how do you integrate with the rest of the server engineering teams and with the SRE teams to use things like centralized monitoring systems and alerting systems. So we'll cover 5 examples of how developers through their microservice integrate with these teams. The first one is routing. Initially, when we started the microservice framework, there were no publicly accessible microservices. They were all behind the series of web servers, but slowly but surely, there were people who wanted to expose their particular services to the public. So from a browser, you could call location service to tell you what to do for a particular customer that was in Europe to figure out whether you should charge them VAT or not. So that's what actually happened. So you have one path, which is stuff that is websites that go all the way down to our web server fleets, or particular endpoints that, like location.squarespace.com, that reach our load balancing and reverse proxy layers and have to be routed differently based on the URL or anything else that might appear in that particular request. This example is just based on the URL where you see location.squarespace.com, you send it to the location service fleet. Now, in order for this to happen, the reverse proxy or the routing layers need to understand service discovery, or at least know how to determine which servers conform the location service fleet. So what we did in our edge infrastructure team is that we instrumented our reverse proxy, which is based on Netty, to provide a simple language. And this is, forget the name of this language, Clojure, yes. It's a Clojure. It doesn't really matter what language it is. The important thing is that near the bottom, you see a template. You're defining a backend called the location backend that says that for like all the servers in that backend will be the ones in the inventory files that are labeled EQXDAL location. So these are our location services in our Dallas data center. So this is a Jinja 2 template. You pass it through Ansible, and you generate the thing to the right, which is the same closure definition, but with the actual location services populated for you. So you can deploy that to our routing tables, and your service will begin to receive traffic. At our reverse proxy layer, you see a UI where you can verify that actually the location backend has been populated with your services. The next thing, apart from routing, is the web application firewall. As soon as you expose your services to the public internet, they can be target of attacks. So you need to block those attacks. What happens here at Squarespace is that you have actually within the reverse proxy, a web application firewall that will kick out any sort of traffic that seems to be attack traffic. But usually it was only for our web server fleet. What we gained for free by doing the routing at the reverse proxy layer was that we could apply the same rules for blacklisting, whitelisting, where is it? So you can see here, blacklisting, whitelisting, throttling of requests, all that type of logic to also your public microservices. So we gained this for free. The other one is integrating with SRE's managed Ansible repository and inventory files. If you want to service, you will be provided a bunch of servers in the individual environments for you to use. In this example, let's say I'm building a namespace service. You will get servers spun up in the staging and the QA and the production environments, and you are free to use them as you need. You're also free to request more servers or less. By default, we give you 3 for redundancy. Since we use Ansible all over the place, we use Ansible for everything here at Squarespace, we have defined a series of Ansible best practices by which we expect anybody that interfaces with our repo to follow. However, as a developer, I'm mostly interested in my case, a Java application. I don't really care about the Ansible repository. What I need from Ansible is a way to inject values such as server fleets, passwords, that are not exposed to the code, stuff like that into my configuration. So in order to do that, we developed an Ansible repository interface contract that tells developers exactly what is available for them to use in their configurations for their microservices. So if you want to, let's see an example here. Well, if you want to interact with Graphite, we give you that through the Graphite host and Graphite port variables. And as long as you template those variables in your configuration file, they will be added dynamically during deployment time. So an example is here. This is the hello service. I have a deployment YAML here in Ansible syntax, and you can see that I defined some Sensu alert subscriptions. So it's integrating with our alerting framework and some log/shipped logs. So it also integrates with our ELK centralized logging framework. And I can define which types of, actually I just list which files I want to ship to ELK, and they will happen for me. And similarly, when I define an alert subscription, I know that if I'm subscribing to the Squarespace servers, all of the alerts that are part of that subscription will be run on my services. So disk usage alerts, whether your server is up or not, stuff like that. And then for the configuration, which is where your microservice integrates with the Ansible repository, you see examples here of grabbing all of the Zookeeper hosts through a template, injecting the Graphite host in the Graphite port, and even using passwords that are stored in Ansible Vault into your microservice and put there dynamically during deploy. So now I have all these fancy things. I have a repository and I have a Gradle file. I know how to build it. I want to integrate with the tools that SRE provides to build and deploy my service. We use Bamboo throughout our company to do so. So you can see an example here of the taxation service. You have a build plan defined. And what we do is that every 15 minutes, we collect any commits that you have, and we give you a new release that you can deploy if you want to. And if you don't have to. Within the same build plan, you can also see all of the environments to the right for where you want to deploy your particular release. It might be the different production environments that we have across the country, or the staging environment, or the QA. And when you actually execute a deployment, as I mentioned previously, that integrates very tightly with Ansible. So we handle your deployment entirely through Ansible. And we have things baked in there like intelligent health checks. So that if, let's say you have a service fleet of 10 servers and you have a configuration that you will deploy to 3 of them at the same time. So you will have 4 waves in the end. When the first wave completes, it checks that the servers that were just deployed to are healthy before going to the next wave. Once the second wave completes, it not only checks that the ones that it just deployed to are healthy, it also checks that the ones in the previous wave and the first wave are also healthy, because we found that sometimes the servers take a little bit of time to die sometimes. So we continuously check your servers as the deploy goes through, and we stop it if we see any sort of behavior that is bad. We do waves, and we do intelligent health checks. Monitoring and alerting tools. This is one that is quite painful for many developers. You can have the best time series database, the best dashboarding system out there, but the fact of the matter is that your dashboards will become out of date. You add new endpoints and you have to manually add them in there. So it's a big pain to keep this up to date. So what we decided is that as part of using our framework, we will give you your dashboards for free. We will generate them for you using the Grafana APIs that it exposes. So if you have the same taxation service put in there, you can see one dashboard at the top that was manually created. But our system, as soon as the service comes up, it will call into the Grafana APIs and put the dashboard based on the latest endpoints that it has available and defined. And it will do so for the different environments that you have. So in this example, you have taxation service, not only in production, but in staging. And it also gives you 2 types of dashboards. The first type of dashboard is what we call just a generic dashboard that will tell you not only how things are doing from the service client point of view, but also from the server itself. So from the caller and from the receiver. We find that sometimes the caller says that everything's broken, but the server says everything's okay. So there's something in the middle that is not okay. So we provide to the developer the client-side metrics and the server-side metrics. And if you were to scroll down here, you get a bunch of systems level metrics, like how are the CPU, memory, and other types of metrics doing. And then the other type of dashboard is the API dashboard. And here we give you, for every single endpoint that you have defined in your microservice, the request rates and the latencies for those endpoints. So you can see an example there. As I showed you in the deployment YAML, you can define the types of logs that you want to ship. And all of those get shipped to our centralized logging aggregation framework, and you can just search for anything that you need. And as I also mentioned towards the beginning of the talk, you have a context ID. So if you have a problematic request that you have identified, if you just put the context ID into the search bar, it will tell you what all of the services that were involved in fulfilling that request. So you get the full power of the aggregation framework. So with logging and with metrics, you're not going to look all day at dashboards or keep searching logs. What you want to do is to have an alerting framework tell you when something is going badly. We use Sensu very tightly integrated with Ansible to do this. In this example, I have the same taxation service, and it tells me for that particular instance of the service, these are all of the checks that are running on it. And you can't really see it there, but you can, Sensu is based on subscriptions. So for anything that is subscribed to the Squarespace servers list, you can see that it's running the disk usage alerts, the swap alerts, the RAM alerts, and those will fire and use the appropriate handler that have been defined. So in this particular example, if the taxation service were to fire for any of these checks for any of the instances, the particular team that owns that service will receive those alerts. So that is also part of our whole strategy or philosophy behind microservices. You won't build hundreds of microservices and have one single SRE team support them. We provide you the ability to build microservices, but you yourself as an owner, as a developer, and with your group of developers, you are the owner completely from end to end for your service, including being on call for it. Okay, so the last piece is you have a framework. We've been developing this framework since June of 2014. It works pretty well. How do you get other people to use it? How do you make it simple and stress-free to build a microservice? And I will cover these three aspects. The first one is if you tell a developer, hey, we want to build a new service to support gift cards on Squarespace, they shouldn't even have to think about how they do that. So you need to provide tools to them to write a command line or click a UI to generate a repository for their service. So we build a utility tool for this based on Yeoman. I don't know if that's how you say it. And all you have to do is say, yo, I want the core service. And then you type the things that you want your service to have. So in this particular example, I'm building an operation service. I'm using the latest version of Tyson and the latest version of the service client. And I define my Java package, my base Java package, and it will generate a bunch of boilerplate code for me and create a repository, a Git repository that I can then push into our Bitbucket or GitHub accounts. So now you have the base for your microservice. But then what do you do as a developer? Like, I don't know what my next step is gonna be. What we also wanted to do was provide a very simple way for developers to define their endpoints. So it's like a DSL for defining your particular endpoints for your service. And it supports different types of data types and responses and all the things that a developer would need. And as more and more developers start using this API-driven mode of development, we add more features for our clients. So in this example, I'm defining an endpoint for the location service that says IP's IP, basically get an IP by address. And I define my parameters, my operation ID, which will be the name of that endpoint, and a bunch of different things to define that endpoint. And then what I do is I run a generator to build all of the boilerplates that is required to define that endpoint as I have set it here. So in general, you can build a repository with all the boilerplate code to have everything that we have baked into the framework. And once you have that, in an API-driven fashion, you can define your endpoints and generate all of the boilerplate for that. So the developer, in the end, all you have to do is focus on your business logic and build that out. Another thing that is very important is previously, years ago, we only had a monolith. So everybody knows how to monitor one monolith, the same dashboard. You can see latencies for everything. And if you're lucky, the developers instrument the code to see metrics for particular things that happen within the monolith. With a microservice framework, there are so many things happening everywhere, and you need a centralized way to understand whether a particular fleet is healthy and have links available for you to quickly go to tracing or to dashboards or to the alerting UIs so that you can dig deeper. So we built the service dashboard that lists every single service that has been registered through our discovery mechanism, and you can drill down to a particular fleet. So in this example, I'm running the service dashboard for our Dallas production data center, and I can filter by the taxation service. So I have 3 running, and they're all up. And then I have buttons to go anywhere I need. It might be Grafana, API documentation, the actual source repo, or anything else like distributed tracing. And if I were to click into one of those instances, I get a bunch of information about how that service is doing. So, well, first and foremost, you get links right there to Swagger, to Hystrix, to Grafana, and to the tracing UI, so you can dig deeper really quickly. And you get a bunch of information there that I can show you live for what it does. So you can see metrics here, which are the same things that are being written to Graphite. You can see logging levels, and you can actually dynamically change the level of logging for a particular package in case you're trying to figure out a bug in production or in any environment. You get JMX metrics, and you get even the threads if you want to deep dive. So it's really powerful, this service dashboard, and we're continuously trying to add more and more features. I forget what this is based on. Do you know the name of that project? The Spring Boot admin, all right? So this is what you get also for free. If you're registered, if your service is registered in any of our environments, you go to the service dashboard for that particular environment and data center, and you get all of this information for free based on our framework. And the last thing that we actually started building this out in our Hack Week. We have Hack Weeks every 3 months or 6 months, depending on whether we remember to do it or not. And we decided that it would be really useful and insightful to see a graph, a live graph of what is happening in our production environment or any environment when it comes to services calling themselves. So in this example, I'm clicking on one of the services and seeing how that fans out into a bunch of other services. And the dots on the lines for a particular edge identify how busy that service is. This is based on the Visceral project from Netflix. And you can also even see if one of these services goes bad, the line or the circle there will become red, and it will tell you visually that something is wrong. This is pretty cool, but usually what I want to see is the high-level view. And this is the service graph of what is actually happening in your environment. And you can see things going crazy between the web server fleet and the billing server, and the auxiliary fleet and the billing server. And so it's really useful to see it live what is happening in your production environment and what are the edges that are super critical that they are up. This can also inform how things like capacity planning when you're looking with SREs as to what you should do with your service. So in the end, what you have is a very robust microservice framework that we call Tyson with all of these things. At the top level for applications calling microservices, a very robust service client. At the core level, a service framework, a service core framework that provides all of these neat features for you for free. To the left, integration points with different teams like Edge Infrastructure and the SRE team. And at the bottom, ways to promote the use of your framework so that people code less on the monolith and start thinking about microservices and building those out, and ways to make sense of all the madness as more and more people build services. And that's it. That's all I had. Think we have time for questions or no? Yeah. Anyone has any questions? Go for it.
Hey, yeah. First of all, great stuff. Really, really impressive what you've done here. Wondering if you could talk a little bit more about the traceability. You also had mentioned client-side monitoring. So I'm wondering if you meant the service client or actually the end user client, and if you can trace from the end user all the way through to the infrastructure and how that's working.
By end user, you mean like a visitor on a website?
Sure.
Yeah. So what happens when either a customer interacts with our platform or a visitor goes to one of our customer sites is that we get that request at our edge layer, so load balancers, and that flows through the component that I called the reverse proxy. When it gets to that point, it's when it initially makes the context ID. Once it makes the context ID, it routes that request to wherever it has to go. It might be the web server fleet. And then that web server fleet through a service client calls out to another microservice. It doesn't generate another request, a context ID. It uses the same one that it was generated at the first touch point. So that's where you can actually see for this customer or visitor that loaded your site on Squarespace, it was slow, and you can see everything that happened in that request.
Customers.
Yeah, so we don't provide anything in the service framework to give you insight into that as a developer, but our network engineering team and a bunch of tools that our SRE team builds give you an understanding as to whether a town in Europe is having an issue with connectivity through an AS number. And we have tools that tell us there's an issue here, and you can actually do the BGP play to understand whether there's an internet connectivity issue elsewhere in the country before it even enters our infrastructure, which is a really good question, because as you grow bigger and bigger and you have millions of customers, you have about 500 customers writing into your customer ops organization telling you that there's an outage, and SREs take a look at our graphs and there's nothing, like everything looks healthy. So it's an issue with an ISP somewhere around the world.
Hi, great stuff. Thank you very much for sharing and talking. Your use of Uchiwa and Sensu, are you using the open source Uchiwa dashboard? Have you added any RBAC or like individual user authentication to that dashboard? Is it what's that specific thing look like? Are you providing individual Uchiwa instances to each of your internal clients, or an individual dash per application or microservice?
The way we structure it, first to answer your question about authentication and authorization, Uchiwa, as far as last I checked, does not provide anything like this. So what we do is we configure it with an Nginx layer on top of it that integrates with our LDAP system, and you cannot view it unless you have access to view it.
So you do the authentication at the reverse proxy and then basically just disable it on Uchiwa.
Yes. And then the other thing is, how do we set it up in our infrastructure? We have it's actually one Sensu instance, and SREs can correct me if I'm wrong, per data center and per environment. So if you have our Dallas data center with production staging and QA, you will have one Sensu server in each of those with one Uchiwa instance, but I believe you can view everything from one, right? We had a way, you don't want to figure out where to go for a particular Uchiwa instance. So we have a single URL where you can actually view all of the alerts across all of the particular Sensu servers in an aggregated way. So I can actually show you, I think.
How many clients do these Sensu servers support approximately, each of them? Okay.
So here you can see all the different environments and data centers, and you can drill down into any one of those.
Do you have any Windows clients in here, or is it just Linux?
Just Linux.
Awesome. Thanks.
First, thank you for giving the talk. I thought it was a great kind of bringing together all of these tools into a kind of comprehensive package. Two questions. One is, I know you guys used Drop Wizard in the past, and then you mentioned Spring Boot. So pros and cons, what you guys think of one versus the other. And then the other one is, you didn't start from this, like, did you start from the grand vision, or how did you go through that transition of the monolith to the microservice and all of these features? Was it piece by piece, or what drove, each of those features and so on?
Yeah. So I'll take the second question. The first one, I'll give it to an engineering manager that runs the team that builds this for the Spring Boot versus Drop Wizard. So the second question is, what was our journey? So we started this as a Hack Week project. I had recently joined from Amazon, and I had this mindset where, of course, everything has to be a microservice. But if you have 30 developers, you don't necessarily need to do that at that point. So I'm happy that we started early, because once you reach 100 developers or 120 and soon 200, having a monolith will just break your entire workflow. People, by mistake, commit something that blows up the servers, and you have no way to recover. So this was our way to think 2 years or 3 years in advance for what we needed to do or start to doing today, so that we wouldn't burn the whole Squarespace platform when that time came. And what informed the feature set? The first thing we did was a Squarespace client, the service client, and we built on Ribbon and Hystrix, and we made that work really well. And slowly, as more people, actually we were our own consumers for the framework, we started building services on top of it. So people would say, oh, it'd be really cool if we can generate the services and we can generate the endpoints based on models and stuff like that. So we mostly drove the feature sets that we wanted to see in the framework.
Yeah, I also think it's important to mention that we started this before a lot of the Spring Boot cloud stuff came out. So a lot of the integration with the Netflix open source was done prior to Boot being in existence, really, or being popular for that matter. In terms of like why we chose one over the other, it's still, I think for the most part, it really came down to like the technical decision that Drop Wizard was. It was great. It's great at doing like the small things and doing it quickly, and then starting off quickly with a service. But I think when it came down to like a complete package in terms of a dependency injection layer, integration with third parties like Kafka or Rabbit, Spring Boot just provided a lot more in that regard, and it was quicker to get set up. And like it came down to, at the end of the day, like, do we want to build all this stuff ourselves, or do we want to like leverage a lot of what the Spring Boot team has done? And so we chose to use the Spring Boot team. You want to add anything, Doug, or you guys? I think that's, but Drop Wizard was great. And I mean, you can see actually in a lot of the slides that we still have some of the variables named Drop Wizard, but it was a clean migration. We're actually in the process right now of moving all our services over to Spring Boot.
Any other questions? Yes.
Oh, sorry.
So it looks like you have the services mapped to individual servers, and y'all run your own data centers. Do you end up with like a lot of sort of like bits of compute that are left over, or kind of like unused, compute resources, or do you try to, resize things on VMs that are the appropriate size to service, or how does that work for y'all?
So we have general defaults that we provide to any service owner. It depends on the type or the use case of the service that you're going to build. And with having a conversation with SREs will lead you to receive a service that has more RAM or more CPU based on your needs. So for example, we have a screenshot service that makes use of containers. And I believe what it is that has to max out, I think it's RAM or CPU, we can build a configuration for a specific VM that will fit your needs. So it's boilerplate in that many of the things are defaults. Like we give you 3 instances in every environment with some default RAM, CPU, and other stuff, but you can request whatever it is that you need. So if you need a caching service and you want a bunch of RAM, we will give that to you. Regarding, I think you asked about over provisioning or leftover resources. We are still trying to reason through that, and where we have a lot of investment in things like Kubernetes, where we don't necessarily want to get a ticket every time a developer wants a service. We, as I said before, we want to make it completely self-service to our developers. So you might say, I want the service, I want it in all environments, and I want it with this configuration for RAM and CPU, and it will get put somewhere. And we don't necessarily care where, we just want it to be super fast and super easy for the developer to receive everything that they need with no SRE involvement. But that is, we have some prototypes in place, but we're not using it. We're not using Kubernetes right now.
Hi, everyone. So I'm John Sullivan. I ran the operations team at NS1, and I'm now over on the product side of the house. So we're a managed DNS provider that specialize in traffic management, and it's API driven and lots of intelligence at the DNS layer. We happen to power Squarespace.com, and if you sign up for a website, records get injected into our platform, and it's nice and tightly integrated. Yeah, echoing everyone's sentiments, a super interesting talk. Makes me really happy that we're not a layer 7 application. Just the complexity and the thoroughness with which you've got to pay attention to things is pretty impressive. I wanted to know, aside from the depth of the automation that you've got, and the transition from a monolithic application to microservices is challenging enough. How does your notion of monitoring change along with that? Because I'm imagining at one point you probably cared about the amount of and wanted to get woken up when disk space was filling up on some server. That has to go away at scale. So how do you treat that and make sure it's not kind of getting lost in the noise?
So when I joined and when we were building out the SRE team, there was very low visibility into many things. So I remember I joined and I was a developer in what we called the server engineering team. And I was at that point moving away from Solar into Elasticsearch. And I changed everything. I changed all the code. I was ready to deploy it to production after testing, and I deployed it. And I had no insight as to whether the latencies were affected, request rates were affected, nothing. There were no graphs for anything. And it sort of freaked me out because I came from Amazon where you get all of that for free. And I remember at that point, I told my boss, the VP of engineering, hey, maybe it's a good idea if I spend a few weeks, which turned out to be a few months, building a monitoring system that will give a very effective feedback loop to our developers. So that's when the journey started into monitoring. And it's been a long time since. We now have not only monitoring frameworks through Graphite, but through ELK also, and all the different tools that I showed you here. But more importantly, we have a system that no longer depends on the health of one single server. We have distributed that architecture such that if one of the servers dies because it has high disk usage, I don't have to wake up at 3 in the morning. I can look at it at 9 in the morning, or the people who wake up in Dublin at 3 in the morning my time will look at it. So it makes it much more pleasant and much more human in the operations point of view. So at this point, we even stopped any RAM alerts that we would get. Many of the services do not have high CPU usage alerts anymore. And we just define which are our service level indicators that we actually want to be woken up for, or the particular owner of that service wants to be woken up for, and then put some alerts based on those.
That's awesome.
Thank you.
Let's see here. So it seems like you've made debugging very easy. Really like the dashboard where you can drill into either Elk or Hystrix or whatever the sort of related system is, or find the trace ID. How do you decide what metrics actually? So you mentioned you're not monitoring on RAM usage or anything like that anymore. What are some indicators or some examples of things you would monitor for, or things that are indications of big problems?
So even if we don't alert on things like RAM and CPU usage, we do not stop emitting those metrics, because if you alert on them, they might be a symptom. But once you determine, like you have a service level indicator that says people cannot log in, and then you drill down and you figure out because the Redis server has super high CPU usage, and you start learning more about the issue. If you weren't to have those metrics, then you're blind. So what we decided was we will emit as many metrics as SRE wants or a developer wants, and all we need to do is build monitoring systems and time series databases that are able to handle that load, so that when a developer actually needs that information, it will be there for them.
And is it mostly reactive? You don't really need to go digging until there's a problem. You mentioned capacity planning. I thought that was pretty interesting and kind of want to dig in there a little bit. Or is it is there like a QA team or somebody who does sort of proactively just kind of look through the matrix data and kind of see what's going on under the hood?
Capacity planning specifically,
or for some of the services, is there a dashboard that kind of gives you maybe it was the Hystrix, the big linked diagram series?
Yeah, so as in a developer in their day-to-day will use all of these tools, Hystrix, Grafana, alerting, stuff like that, and that will inform their decisions. There have been cases where, say when we launched SSL for custom domains, we didn't necessarily know how big we needed to make the fleets, especially ones that needed to be of the same scale as our reverse proxy layer, because they have to terminate traffic for everything that enters our platform. So at that point, we would say, okay, we're gonna make it of the same size as the reverse proxy fleet, but we didn't know. So you release features, and then based on all the tools that you have, you use that as your feedback loop to determine whether you have to scale back or scale up. And so that's as soon as you launch things. But then in a quarterly basis or a 6 months basis, you have to take a look at your service and determine, maybe you have 3 new consumers because you built a very generic service. You have to make that part of your capacity planning, so that you're preempting anything that might go bad. So you might say, I need to add 2 more servers because of so and so and so.
You mentioned TSDB in there, and Influx 1.0 RC is out. There's been a lot of development in that space. Graphite 1.0 RC is coming out. Influx is obviously making huge strides. That's a sort of an active area of development that has seen a lot of interest over the last couple of years. How do you think about kind of evolving that part of your stack? I mean, it seems critical.
Yes.
What are you evaluating kind of moving forward, or how do you evaluate that and other new technologies to add into the stack?
Yeah. To add one thing to your previous question, another thing that makes capacity planning critical for us is that we operate our own data centers. So if you really want 20 more VMs, that might mean that we need to order 3 more ESX servers. And that means that there's a 1 month long period before that ESX server even arrives to our data center. So you really need to be proactive about that stuff. And related to Graphite, we are at the breaking point almost in the next couple months of what a well-designed Graphite architecture will be able to handle for us. And this is across data centers, and the servers in a particular data center only emit metrics to the Graphite cluster in that data center, so that we don't have metrics all over the place, because it does not scale at this point for us if we do that. At this point, we have 4 million metrics per minute being ingested for each particular Graphite cluster in every data center. That will, within 6 months, we will blast through that, because more people are building microservices and different metrics are being.
So that's top of mind for you.
Yes, and we're excited about Graphite 1.0, and we're also looking at other alternatives. like Influx, like something backed by Cassandra, and even things based on the Gorilla paper that are coming out there.
I think the idea that you just hit on, that a developer can request resources, like you're giving maybe people a lot of rope to hang themselves with. And I like the idea of an SRE team that enables the developers to own the product and not throw it over a wall and force somebody else to support it. Is that kind of a culture shock for people coming on board, or do people tend to kind of fit into that and
So
adjust?
we've learned as we've grown our SRE function here at Squarespace. When we started, like the book wasn't out, so we couldn't really know what Google was doing. And not only Google, we've spoken with people at Facebook about how they structure their production engineering teams. And what we found that has worked really well for some of our teams is that we embed SREs in particular development teams. And that SRE functions as part of their team. They go to their stand-ups, they go to their planning meetings, and they even take tickets in their queues and work as another team member. So that makes it much smoother when somebody who, as you say, maybe they never known what it is to ask for a new VM, or how do you monitor that infrastructure. They have a person right there next to them every day that will help them in that onboarding process, so that in the end they effectively become an SRE, because they capture that mindset of how do I monitor things, alert on things, and operate my own infrastructure and my own service. And more importantly, how do I become on call? And that is really important, because if you do not feel the pain of what you're pushing into production, you will never fix it.
Right.
So we turned it back around. Instead of you throwing stuff over the wall, we will give you SREs. We will train you to how to properly monitor and operate your services, and you will learn.
It's like you've given a sort of a human API from the SRE team to the individual developers or the development teams. Let's see what else I got. So you guys are continuing to experience ridiculous amounts of growth, which is great, and congratulations to you and the team. I'd imagine, I mean, you just mentioned some of the metrics challenges that you're facing. What are, were there challenges 12 months ago where you set out to solve them, and then the goalpost rapidly moved, or a thing that you were really confident in, and then as soon as it was deployed, like the growth outpaced it?
I think the biggest pain we have right now are different technologies that we use from different vendors, things that we do not build ourselves and therefore do not know how to necessarily debug. So we find ourselves sometimes QAing the technologies for the other particular companies, and that is very frustrating. It's very frustrating because for absolutely no reason, because the traffic increased by 1%, all of a sudden those dependent components are dying and you have no idea why. And no matter how much instrumentation those vendors provide to you, you still do not have the quality of metrics that an SRE would have or a developer would have for something built in-house. So we've run into those things, and that leads us to change the technologies that we use or spread them out into different clusters. So that would be one. The other one is, as we build out this microservice or service-oriented architecture, even if we say we have best practices, sometimes they're not followed. So you might have a microservice developer building a completely segregated service that actually uses a shared database. And all of a sudden you have some person deploying some code to one microservice that breaks the database, and that other service developer has no idea what changed, and it becomes really confusing. So trying to manage that as more and more people build microservices, adjusting our best practices so that things like that don't happen.
So you've been here for 4 years now, is it right? What do you kind of envision the next four? There were the challenges from here in the next couple of years looking like?
Next 4 years. So I'll go back to the vendors. We have to change something there, because it is not okay for, as you have millions of customers on your platform, you need to be able to achieve some level of nines with some level of confidence. And right now we can't because we have no control over some things in our architecture. And some of the things are our own doing, and some other things are things we have no control over. So that I foresee, not even in the next 4 years, in the next year or a year and a half, changing some of the choices that we've made in the past to replace those technologies, to change how we architect things so that we can grow into the future. And then separately, as we grow fast and we double our engineering capacity here in New York and all our other offices, I think we will be thinking, do we really need to operate our own data centers? And that will be informed with how fast we can provide what developers need to do their jobs. If we find ourselves unable to do that, we might need to branch out and use public clouds. I think that regardless, we will use public clouds because, again, as we become more of an international company, or our customers become more international, it is not okay that a customer in Australia has to come all the way to the origin in New York or in Dallas or wherever it might be to load a website. We need to have the capacity to build edge pops all over the world, to push our content there and solve the really hard problem of cache invalidation, especially as people change their websites. How do you ensure that all that content is pushed out all over the place? And I don't foresee us building like points of presence ourselves in all of these regions.
Yeah, there's always the line of how far does your application extend, and are you a hosting company at that point? And or do you let somebody else kind of take the reins on that, with the caveat that you lose some control over what's going on there? So we experience the same thing ourselves with transit providers and all sorts of infrastructure that we don't want to be doing but have to be doing just by the kind of the virtue of the nature of the business. Last question I had is if you could go back in time a year or two and warn your present self about a challenge you were going to be facing, maybe in the stack or organizationally, what would that be?
Organizationally, I think one of the things that I think we could have done better, or I could have done better, is do this. Share with people what it is that we're doing here, because people don't know. And at Squarespace, everybody hears us in podcasts and our Super Bowl commercials, but to them, we're just a consumer technology. And what happens within Squarespace, within the engineering organization, is widely unknown. So we want to share the things that we've done, interact with the community, and hopefully in that way, build a much bigger presence in New York and attract the talent that we need. That is one of them. Other things, I think I would have done things differently with the way I structured SRE. That it's been almost 3.5 years at this point since I took that team over. But like I didn't have information at that point as to how to best structure an SRE team so that you don't have that problem of developers shoving stuff over the wall. However, we did do something, which was to start developing the microservice framework and start making those developers owners of their own things to flip it around to them. So it's, how do you try some things and you fail at some, but you do well in other ones. So little by little, one step, how is it that they say, 2 steps forwards, 1 step backwards, and then in the end you reach your goal.
Great.
Well, thank you very much for coming.